Welcome to part 3. Finding slope. Now, we don't need the graph points to find slope. We use our equation for slope. M equals y2 minus y1 over x2 minus x1. And that's what we did actually in the previous problem. And works quite well. But after I do this, I'm going to explain why it works. All right. Slope is really the foundation of all this graphing of lines and a lot of the work we do here. So it's really good to understand what it all means. So okay, so let's say I'm going to make this this my first point and this my second point. So this will be x1, y1, x2, y2. And it doesn't matter which one you make as 1 and 2. Just once you do decide, you got to stick with them. Okay, so let's do this. Y2 minus y1, so 2 minus 3. Oh, I didn't need to do that. Over x2 is negative 8, and that's minus a negative 4. Here's where I need to do that. You need to use a parentheses. When your number, your x2 or one of your coordinates is negative, you need to use a parentheses so you don't forget about one of the negatives. Okay, and then we solve this. 2 plus a negative 3, or 2 minus 3 is a negative 1. And negative 8 minus a negative 4 is the same as negative 8 plus 4, which is a negative 4. And that equals 1/4. Okay, so our slope is 1/4. Now, that's all we have to do for this. But I think I would like to plot these points just to show you what it means. So negative 4, 3 is right here. And negative 8, 2 is right here. And our slope is 1/4. So notice, we go up 1 and we go over 4, we get to the other point. Okay, so if we graphed the line that those points go to, that make the slope, we can see that we see the slope of the line graphically. And notice that it goes up 1 and it runs 4. And it does that all along. So if you start at this point, you go up 1, you over 4. 1, 2, 3, 4. You're back on the line again. And if you did it the opposite way, if you did a negative 1, if you went like from here down 1 and back 4, 1, 2, 3, 4, you're back on the line. And what the slope is, all it is a ratio between the rise and the run. It's rise over run. And to get rise over run, you got to subtract the two y's. You subtract the two y's, you get this part. You subtract the two x's, you get this part. That's why the formula. Hope that's clear. Okay, there are, well, number 26. I'll read the problem first. Find an equation of the line with a given slope that passes through the given point. Given slope being 4, given point being negative 3, 2. Write the equation in slope-intercept form. Okay, so we have 3 formulas that we use a lot when we're graphing lines, working with lines, finding the equations of lines. And those are the slope formula, which we've already used, and then 2 formulas that come from the slope formula, the slope-intercept form and the point-slope form. So we're going to use both of them to do this problem. Either one will work. the point slope form is y minus y1 equals m times x minus x1. Of course, the m is our slope, and the y and the x, that's any point. So that's any point on the line. So that's part of finding the formula. The y1 and x1, that's where we put the particular point in. So we'll do that. We'll put in 4 for the slope. Then we'll put an x and minus. And x1 is our point there. -3. And then y minus y1, which is 2. Okay, and now we're supposed to put this in slope-intercept form, so we have to simplify this. There's nothing to do on the left, so we'll just recopy that. Y minus 2. On the right, well, first we want to take care of that -3, right? So let's do that first. X, that turns into x plus 3. Alright, now we'll do the distribution. 4x plus 12. Okay, so this is a 2 over here, by the way. Okay, so now I guess we'll add 2, because we want to have it in slope-intercept form, so we have to have it y equals. So we're adding 2 to both sides. And we get y equals 4x plus 14. Okay, so now we're going to use the other formula. The point slope, or the slope-intercept form. Y equals mx plus b. Okay, so we have our slope. Y equals 4x. But we don't know our y-intercept. Because the point they've given us, this point over here, is not the y-intercept. However, that point is on the line, so it's got to work in this equation. So we can stick that point in. We'll put in the 2 for the y, and it's 4 times the -3, and that's plus b. Notice we're down to one variable. If we have one variable in the equation, we can find out what it equals. So we just simplify this. 2 equals -12 plus b. Then we add 12 to both sides. And lo and behold, our b is 14. Notice that that's the same y-intercept we found before. So we just plug that in. We've already got y equals 4x. And then we stick in our b, plus 14. And that's it. You can use either formula to solve for this. You just have to know that when it's not 0, 0, 2 or 0, 5 or 0 something, that's not the y-intercept, so you'll have to find it. Okay. Number 27. Write an equation that models the described quantity. Specify what each variable represents. You know, when you hear the word models, that means it's taking a real-life problem, and we're using an equation to model it, to show how it works, show the relationship between the two different things. In this situation, it's a worker has already earned $300 and is being paid $9 per hour. See, so this has to do with the amount a worker makes and how much he's paid by the hour, how many hours he works, and the relationship between the hours he works and the amount of money he makes, right? So you can create an equation that shows that. This is very specific. It says he's already earned $300. And so you have to know what that means. If he's already earned, that's the starting point, and then he's being paid $9 per hour after that. So if he's already earned $300, then every hour after, every hour he works is going to be money added. So like he has $300 and he works 1 hour, that would be $9. And he works 2 hours, that's $9 more. 3 hours, $9 more. So then we have 327 for 3 hours. But you see, it's not just 3 times 9 giving us 27, see, because we've got that starting point of $300. So that's how it gets to be 327. So whatever number of hours the person works, it's going to be added on to the 300. So we can make an equation, and of course that 300, see, that 300 is added on to the end of the equation. This is where we use that formula, y equals mx plus b. B, that's that y-intercept, that's our starting point, and the m, that's our slope, which is our rate. Our rate is so many dollars per hour, or pounds per minute, or miles per hour, or it's a rate. It's something per something else. So, like if we were going to graph this thing, which I'm not intending to do, but he already starts. He starts off with $300. See, so that's the starting point, and then it's going to go up from there. Adding on to the 3 for each hour, like 1, 2, 3, 4. Adding on $9 for every other hour we get. So again, we just plug things in. We could use letters that, like we could use P for how much he's paid, and we could use T for the time, and then the M, that's our rate, so it would be $9 per hour, and the B, that's our $300, because that started out. So see, that makes sense. Whatever number you stick in here, it's number of hours you work. So if it's 3 hours, it'd be 3 times 9, and then you add the $300. So if you had another problem that was like the bathtub has 30 gallons in it, and after 3 minutes it's empty, it starts out with 30 gallons. So the 30 gallons would be over here where that 300 is, and then if you know what the rate it is that the water's going out, you put that there, and you've got your equation. So this could be written P equals 9T plus 300, or I'd actually rather just put it in this way, y equals 9T plus 300. And so our variables mean our y is the total wage, including the $300, and this was going to be x. Our x is our time. Number 28. Given the function g of x equals 2x squared minus 3x, evaluate g of -1. Okay, so we're starting to review a little bit about functions. So I might as well give you a little rundown. We'll use this problem as an example. All right, a function, the function notation, like g of x, is the same thing as y. Okay, so here this function, it says g of x equals 2x squared minus 3x. It's the same thing as if it said y equals 2x squared minus 3x. It's just a different way of looking at it. It's thinking of the function is something that does something. It's like a machine. And what it does, what this function does, this function g does, is it does this to whatever is in there. In this case, in general, it's x. So whatever you put in for x, it does that to it to get g of x, or to get y. So, for example, we'll stick in -1. 2 times -1 squared minus 3 times -1. Okay, and we just solve it. So this is the function doing something to negative 1. Okay, so of course we use our order of operations, right? Negative 1 squared is 1. So we now have 2 times 1 minus 3 times the negative 1. Okay, 2 times 1 is 2. 3 times a negative 1 is a negative 3. And the negative of a negative 3 is a positive 3. So we have 2 plus 3, and that equals 5. So g of a negative 1 equals 5. I like to look at it like this. This is the function g. And functions do different things. Some like the washing machine, wash clothes. Some like the lawnmower, cut grass. Skill saw cuts wood. Different functions or different machines do different things. This function g, what it does is it'll take an x that you put in, it'll square it, multiply it by 2, then it'll subtract 3 times that number, and it'll give you the g of x. That's what g does. So in this case we're putting in a negative 1. That's our x that's going in, and our g of x that comes out is 5. Number 29, evaluate the function as indicated. It says evaluate f of negative 2 and f of 5 given the graph below. So now a graph, it gives us what f of x is doing, right? In this case, what the function is doing. And in this case, the function, it's showing us all of the x inputs, everything along the x-axis, everything along the x-axis here. Those are all inputs, okay? And then it's showing us all the y outputs, which are everything that can be measured on the y, right? So, and remember f of x equals y. It's the same thing as y, right? So we stick in an x. In this case, we're going to stick in negative 2 right here. And what does the function do to it? Well, let's find out. At negative 2, the function is right here. Its value, the function's value at negative 2 is 1. So f of negative 2 equals 1. Okay, let's see what f of 5. Let's see what the function does with 5. We hit the function here. Its y value, which is our f of x value, is negative 2. So this is what the function does with 5. It changes it into negative 2. So f of 5 equals negative 2. Number 30. Determine whether the graph represents a function. Now this is easy because we can just use the vertical line test. So if you run a bunch of vertical lines, an infinite number of vertical lines, through this equation here, through this graph of an equation, you can see, I mean, I'm not making an infinite number of lines, but you can see that none of them, as far as you can see, will ever cut through that graph of the function more than once. They'll only cut through it once. If they cut through it twice, it wouldn't be a function. For instance, a function like this, well, those vertical lines go through it twice, right? So that's not a function. So this is an easy test. If you can draw a vertical line through the function and it only hits, and all of the vertical lines you could possibly draw would only hit in one place, then it's a function. All right. So there's lots of relations. There's lots of equations that are relations that this won't work for. But a function is a special type of relation. A relation is just actually a relationship between x and y. I mean, there's lots of relations. You know, there's x equals y. There's y squared equals x, which is actually not a function. there's x equals x cubed minus x squared plus 1. There's lots of different relations, but only some of them are functions. Let's take a different type of example. Let's say that these are the x's. 1, 2, so I'll put that x. Okay, 1, 2, 3, 4. Those are the x's. And then I'm going to map them to a bunch of y's. Okay, and so A, B, C, and D. Okay, so let's say that A maps to A, or 1 maps to A, 1 maps to B, 2 maps to C, 3 maps to C, and 4 maps to D. Okay, well, this is not a function, and that's because a function, its x's can only map to one thing. They can only map to one thing. So this part of it, this part right here, that x1, 1 for x, maps to both A and B. So that won't work as a function. It's okay. It's okay for 2 and 3 to map to the same one. And actually, if we look at this function over here, we'll notice that, for instance, this point, let's see if I can find one that's right on the dot. Anyway, this point here and this point here, they're both mapping to the same value of y. They're both mapping to 8, negative 8. Negative 8. But each one has its own y. They don't have 2 of them. They only have 1. They only have 1. So it's like how many feet are in a yard? There can only be 3 feet in a yard. There can't be 4 feet and 3 feet in a yard. Or another example would be the sun only rises once a day. There's different times of the year it'll rise at the same time, but you'll never get the sun rising twice a day. So this is the vertical line test is showing us that. If it only crosses in one place, that means that x has a particular y, has one y. It's not crossing in 2 places. Like this is a relationship. This is a relation. That x there has 2 y values, so it's not a function. So anyway, if you can do the vertical line test and your lines only cross in one spot, it's a function. Number 31, determine whether f of x could represent a linear function. If it could, write f of x in the form f of x equals mx plus b. So this is not whether it's a function or not. It's already told us it's a function. It's whether it's a line. A linear function is a line. And there's a special quality a line has in that its slope never changes. So what we need to do is we need to determine slope, and then we need to determine what the intercept is, the y-intercept, right? So keep in mind that f of x is the same thing as y, right? So each of these things is an ordered pair, right? So we have -2, -6. We have -1, -2. We have 0, 2. Oh, does that look like something to you? That's our b. That's our y-intercept. And then we also have 1, 6. Okay, so now we could to find out if it's linear, we could take each of these pairs of points and try them and see if the slope is the same all the time. You know, we can use our formula, m equals y2 minus y1 over x2 minus x1, and try it with each pair of points. Do it with these two, do it with these two, do it with these two. You know, we could try it with all the points, and if the slope always comes out the same, then we're good. But there's a lot easier way to do it. Okay, well, the easy way to do this is to see if its slope changes. We'll first look at x. It goes -2, then you add 1, becomes -1, add 1 more, it becomes 0, add 1 more, it becomes 1. Okay, so that's regular. It doesn't make any jumps. See, so f of x can't make any jumps either. So f of x got to be the same distance between. If f of x is the same distance between each of the points, then we're good. So going from left to right in this. So 6 goes to negative 2 by adding 4. Negative 2 goes to 2 by adding 4. 2 goes to 6 by adding 4. So it is linear. See that? Its slope is always going to be the same. This is our slope, really. The rise is 4 each time. The run is 1 each time. So our slope is 4 over 1, or 4. So now we can just write our equation. We'll go f of x equals, our m is 4x plus, and you remember what our b was, right? Well, where x is 0, y, that's where our y-intercept is. So our b, or y-intercept, is 2. If you didn't have that, if it didn't give you the y-intercept, you could figure it out by keep on going up 1 and keep on going up 4 each time till you got to it, or go the other direction. Subtract 1 each time, subtract 4 each time. You could find it that way. Or the other thing you could do is you could just stick it into the equation. You have your y equals mx plus b, right? We'd have y equals 4x plus b, and you could use any of these points. We could use any of these points and stick it into that equation, and then we'll find out what our b is. And then we substitute. But we don't have to here because it already has been given to us. Number 32. Solve the system of equations graphically using a graphing calculator or by hand. Write your answer and give a sketch of the graph on the answer sheet. Okay, so there's something you need to really understand about this. We've got a few different ways of solving these systems of equations. The system of equations is for us, is two linear equations. In this case, the two linear equations are 2x, y equals 2x, and the other one is y equals negative 3x minus 5. Now, usually when we're solving a system of equations, we'll get one answer. I mean, sometimes, there's when they're parallel lines, like, parallel lines, well, there's not going to be any answer. There's no solution because the lines never cross. And then when they're the same exact line, when they're the same exact line, like this, well, then they share, every single point is the same. Every single coordinate is the same, so there's an infinite number of answers. But those aren't situations that we need to worry about very much. I mean, you have to know that. You have to know that when there's parallel lines, there's no solution, and when there's the same line, there's infinite solutions. Because some of the questions on the test are going to be about that. And you need to know a few different ways of figuring that out. For instance, if you're solving, like these equations, if you solve these equations and you find that they ended up being like 9 equals 9, when you got down and you subtracted everything out, you'd end up subtracting out the x's too, and you'd find, or the y's, and you'd find 9, say 9 equals 9, or some other number equals some other number. That's an indication that they're like this, the same lines. And if you got something like 8 equals 7 after solving the equations. Now, I'm not talking about when you check your solutions. Of course, when you check your solutions, you're always going to you should get this, or the solution won't be right. But it's when you're first solving the equation, you're trying to find out what y equals or x equals. If you end up with this, well, then that's this one, right? They share the same line. When you end up with this, that's an indication that the two lines are parallel and there's no solution. See, there's two lines parallel. Okay, but the situations we're usually going to have are, when we're trying to solve a system of equations, there's going to be 1 point. So you really need to understand what a solution for an equation where there's one solution, what it means. If you look at this, here's 2 lines. So there's 2 equations for those lines. And I'm going to come back to this when I actually do those 2 lines up above there. But notice this spot right here. That's the only place they cross, right? The only place they cross. The point where they cross, well, that's what we're looking for. That's going to be the solution. And what is true about that point in regards to those 2 lines? Well, what's true about that point in regards to the 2 lines is that that point works in this line and that point works in this line. If you have the equations for those lines, it'll work the point. Let's say the point, I'm going to move it up a little bit. Let's say that point was 2, 1. That point would work in both equations. It would come out, as an equality. But that's the only point of those 2 lines that's going to work out that way. The point out here, well, that point will work in this line, but it won't work in this line. The point right here will work in this line, but it won't work in this line. There's only one point that works in both lines. That's going to be that one where they cross. And that's what we're always looking for, whether we're using graphing to find it, we're using substitution, elimination, or using a table, or any other method. That's what we're looking for. We're looking for, and that's why we can do substitution and elimination, because both of those equations are the same at that point. So they're going to work. Their values are the same at that point. So you can manipulate those 2 equations and find that one particular point. So I think that's important to understand. I don't know how else to say it, frankly. Let's graph these 2 points. Okay, so we have y equals 2x and y equals a negative 3x minus 5. Now you can see I've taken a little photo of the graphing calculator. I put them in. The upper left-hand button is y equals. You push that, and all these y's appear. And put one of them in y1, so I put the 2x in y1, and I put the negative 3x minus 5 in y2. Now the next thing you do is push the graph key, and it'll graph. Here's that y equals key right here. I couldn't get it in the last photo for some reason. Okay, but here, after you've got those equations in that I just showed you, right there, then push this one, this key here, the graph key. Now you'll see the graph. Now you can draw that graph. The only trouble with this graph, it's kind of hard to tell what you've got there. It kind of looks like, well, this line definitely crosses the origin, right? But this one doesn't. And it's kind of hard to tell. It looks like this point might be around negative 2, 2. But it's hard to tell exactly. Each one of these, actually it looks like less than 1, less than a negative 1. Or actually greater, I should say greater than like negative 1, like a negative fraction to this point. And then right here it looks like negative 2 on the y. So to be exact about the point where they cross, you're going to have to use this button here, the calc button. But you have to push this, you can't see it on this, but you're going to have to push the little light blue button that has second on it. Push the second, and then this button, which says trace, and the little words that says calc. Okay, so we're going to do that next. The next thing is you go down to 5. Either you can use the down arrow, get down to 5, or you can just push 5. Number 5 is intersect. After you've pushed intersect, you'll see what's on the top picture now. It'll say first curve. So you go down, you push enter on your calculator, and then it's going to say second curve. It'll also give some points. And then you push the enter again, and then it'll say guess. And you push the enter again, and it'll give you your points for the intersection. So like I said, you push guess, and then it'll come up intersection, and it gives you your 2 points. So the point of intersection, this point right here, is -1, -2. So -1, -2, point of intersection. So let's graph that. -1, -2 is right here. Okay, and then we noticed from before that one of our lines, this one, it crosses right here at the origin. And you can know that that's this line here, this is a y1 line, and this is it right here, this one we put in for y1, y equals 2x. Notice if you stick in a 0 for y, the x is going to be 0. If you stick in a 0 for x, y is going to be 0. So the 0, 0, that's the intersect of both x and y. So we know we've got that point. So we've got that one, and we've got one right there. Thereabouts. Trying to get it right on the spot. Not too easy. Okay, so we have one line going straight up through here, and then we have another line that's crossing over and going this way, but we don't know exactly what the angle is. So what wouldn't be a bad idea is to go to the table, right? So you can push second table. So do that now. Okay, so this is what you'll come up. This will come up. It has the x's, the x inputs, and then it shows the y1s and the y2s. The y's for the y1 and the y's for the y2. These y's for the y1 are with this equation we put in first, and the y2 is for this equation. So this is the y1 equation. We need just one more point for this equation right here, for this line that goes through here. Wouldn't hurt. I mean, you don't have to. You could just try to copy the graph the way you see it. But you have to know this intersection point. But if you want to be exact on this second graph, pick a point for it. So these are all y2s. You can pick anything that's in range. How about this -2? Oh, -2, 1. Yeah, -2, 1. That would be excellent. -2, 1, right there. Okay, so now we know where to draw our lines. We've got, this is our intersection, and then one line is going to go through that point, and the other line is going to go through that point. Very easy. We just have to draw the lines now. Okay, there we have it. Now, I'm sure that looked a lot harder than it was. It's just you have to get practice. I had to take these pictures of the graphing calculator and so on, and try to get those lines in there. So if you're going to do it with a graphing calculator, you need some practice. You gotta be able to graph it, or create the graph, and then you want to find out where the intersection is. So you have to use that second calc, and then it's not a bad idea to find the points. So use the table. But we'll do it by hand too. But you need to have practice. You do it a few times, you'll see it's not so hard. Actually, it's quite easy, and it gives you the exact answer. And it's not a bad idea to go to the calculator just to check the answer that you got, to make sure you go to second calc to find out if the point you find from graphing it by hand is the right point. Okay, so now we'll do it by hand. Doing it by hand, you can make a table. You can use the y-intercepts. Actually, the y-intercept way isn't a bad idea for either of these equations. But, okay, because the intercepts, the x and y intercept, because this one we know goes through 0, 0, right? Put in 0 for x and you're going to get 0. And this one here, you put in 0 for x, you're going to get -5, so it would be -5, 0. So you've got those points right away. And if you want to, you can if you put in 0 for y, you're going to end up with a fraction. Yeah, like 5/3. So that's not going to be too helpful. So you can make a table if you want. Or the easiest way, of course, is to use the y equals mx plus b form, which both of those equations are in right now. Now you don't see the b on this one because it would be 0 plus 0. So let's just plot that one. Okay, we have 0 for the y-intercept, and then the slope is 2. the slope for the first one is 2, which equals, we'll change it to 2 over 1 for a fraction. We're going to go, we go up 2 and we go over 1. Right there. Okay, so that's one of our lines. And then the other one, it's a -5 for this one. The -5 is the intercept, so it's right here. And for that one, the slope is a -3. M equals a -3, so that equals a -3 over 1. So we'll go down 3, but we don't have room to go down 3. So instead we'll do its equivalent, which is 3 over a -1. Same thing, 3 over -1. So now we can go from here up 3, 1, 2, 3, and back 1. There's our spot. Okay, so now we can put the two lines in and we'll see where they cross. I'm just going to use the lines I had before because they should work. There's that one. And there's that one. You notice they cross at the same spot. They cross at -1. Oops, -1, 2. And of course you can take that, you've got to take this point and you've got to stick it back in the equations just to make sure you're right. Okay, so if x is a -1, whoops, not -1, 2, it's -1, -2, excuse me. Yeah, I could tell as soon as I was going to stick them in the equation. Alright, you put -1 in the y equals 2x. -1 times 2 does equal a -2. And then if you stick it in the other one, y equals -3x minus 5. -1 times -3 minus 5. It's got to equal -2 if it's going to be correct. So -3 times -1 is +3. +3 plus a -5 is a -2. So that point is right. Number 33. Solve the system of equations by using either the substitution method or the elimination method. Show your work. So I've made two categories here, one for substitution, one for elimination. And we're going to do both. But when you get a problem, if you have a choice, look and see which method would be easier to do and use that. Usually elimination is easier, but not always. In this case, I think substitution might be easier because, well, actually, you could, well, they might be about the same looking at it. I think you just have to multiply one of the equations. They're not set up for either in this case, you know. So, but typically elimination is easier. But you want to get good at both of them because you don't know what they're going to ask you for, right? So we'll do substitution first. Okay, we've got, we'll start with, you have to put the equations in the right form. So actually, we're just one of them anyway, in this case. We're going to do substitution. Okay, we've got 2y equals x minus 4. And the other one is 3x plus 6y equals 0. Okay, so the one that would be easiest to get into the form with either x equals or y equals is this one. And I'm going to do x equals because if I do y equals, we're going to get a fraction in this. And I try to avoid fractions just because they're more work. Not because I hate them, though. Okay, so if I add 4 to both sides, add 4 to both sides. I'm going to get on the left-hand side. See, I can't add that 4 to the 2y, by the way. So I'm going to have 2y plus 4 equals x, because these two 4's, they cancel each other out. They're opposites. Okay, so now I've got something that equals x. Now I take that x and I stick it into this equation. Okay, so this equation is 3 times x, which I'm going to put in. I'm going to put in my new x. 2y plus 4, and that's plus 6y, and that equals 0. Okay, so now I just combine like terms. That's the first thing. The first thing is I'll have to do a distribution here. So I've got 6y plus 12 plus 6y equals 0. And that gives me 12 plus 12y equals 0. Okay, I will add a negative 12 to both sides. Negative 12, negative 12, and that gives me 12y equals negative 12. And I'm running out of room, so I'm going to steal some of the elimination side room. And so I have 12y equals a negative 12. Divide both sides by 12 to get my y alone. And I end up with y equals a negative 1. Okay, now because y equals a negative 1, I stick this back into the equation. And you want to always stick them back into the equation to check. You're going to check both equations to make sure it works. And by the way, you notice when I found x equaling something right here, I found this. I didn't stick it back in the same equation, because if you do, you're just going to get same thing equals same thing on both sides. Now you got to stick it. You got to stick it into the other equation. Okay, so let's stick the negative 1 back in. I guess I'm going to just move this elimination thing out of the way for now. Hope I can't. Okay. Okay, so now I'm going to take that. I reduced it instead. I'm going to take the negative 1 and stick it in for y. So, whoops, everything is moving around. 2y equals x minus 4. Okay, I'll put my negative 1 in for y. 2 times the negative 1 equals x minus 4. Okay, so we've got a negative 2 equals x minus 4. Add 4. Add 4. And we get x equals 2. So our points are 2, negative 1. And I want to try it in the other equation too. The equation we didn't use, we found this with the top equation. This one right here. So we'll use the other equation. We'll try it in this one. 3x plus 6y equals 0. Okay, so we're going to put 2 in for x. So we have 3 times 2 plus negative 1 in for y. 6 times a negative 1. And that's got to equal 0. Okay, so this is 6 plus a negative 6. And yes, that does equal 0. So it works in both equations. So that's the answer. 2, negative 1. Okay, we'll use the elimination method now. I think I'll write the two equations in different colors. So we'll do 2y equals x minus 4. And we have 3x plus 6y equals 0. Okay, so now to do the elimination method, we've got to line up the x terms and the y terms, and they aren't in this situation. So I think I'll remodel the top equation. I'm going to add a negative x to both sides. Negative x, negative x, and that will give me a negative 4 on this side, negative 4 here, and that will equal, let's kind of put them in the same place, negative x plus 2y. Okay, so we've remodeled this equation here to look like that. Alright, so now I left a little space in between them because I want to remodel them again. I want to be able to add the two equations together and either eliminate the y terms or the x terms. So I can see that since my x here in the top equation is already negative, I just have to multiply through by a positive 3, and that will make the x terms the opposites. So let's do that. If I do 3 times this side, and I'll have to do 3 times this side. Okay, do it in purple. Okay, so that gives me a negative 3x, and this will give me 6y, and then that equals a negative 12. Okay, so now when I add them together, so I'm just going to add these two, right? The ones I fixed up. You want to keep this straight. You don't want to get the numbers mixed up because you're going to have a problem. So this becomes a negative 12. This is 12y. These disappear, right? Becomes 0. Now we've seen this before from working with the other equations where we have 12y equals a negative 12. We'll divide by 12, divide by 12, and we get y equals a negative 1. Okay, and then we do the same thing we did with the other side. We stick the negative 1 into, well, we can stick it back into the same equation, and then we'll get our x, and our x we found out was 2, right? So x equals 2. And then we stick them in the other equation, make sure they work in that one. So if they work in both of them, that is the solution. That is that one point I was talking about where the two lines cross, the only point they cross at. And the only point where the point we find, the coordinates we find of 2, 1, 2, negative 1, will work in both equations. Number 34. Solve the system of equations by using either the substitution method or the elimination method. Show your work. Again, pick the method that works best for you. Alright? That will work best with these equations. I would say the elimination method would be good because the equations, our two equations here, are set up in the same format. You notice? The x's are lined up, the y's are lined up. And not only that, but this one here, 2y and a negative 4y. We can multiply the 2y by 2, right? And then it would be the opposite of the 4y. Or we could, actually, the same with here. We can multiply the x's. Okay, so let's start out with the elimination method, just because it'll be easier. Stack them up. 3x plus 2y equals negative 6. And then leave some space. Negative 6x minus 4y equals 12. Okay, so that's room to multiply the top. So multiply the top, and then then I can fill it in between by 2. I'm going to multiply this by 2 also. So left side and right side both by 2. So 2 times 3x is 6x. 2 times 2y is 4y. 2 times a negative 6 is a negative 12. Do you see what's going to happen here? They're actually the same equation. If I multiplied through this equation by a negative 1, see, watch, well, this would become a negative 6. We'd have a negative 4y and then a positive 12. They're exactly the same equation. So right away, you can see that if they're the same equation, they're the same line, and there's infinite number of possibilities, infinite number of solutions. So this is obviously the way to go with this and the answer to it, but I'll show you. See, we're going to add them together. We're going to get 0 minus 0 equals 0. 0 equals 0. Same on both sides of the equal sign. So infinitely many solutions. And you could do a substitution method, which would be actually more work, and I'm not going to do it because we already know the answer, and it's not going to be a single point. So as soon as you notice that both the equations are exactly the same, or you're going to end up with 0 equals 0, both sides of the equal sign are going to be equal, you can stop and write the answer, which is infinitely many solutions. Number 35. Decide whether or not the ordered pair is a solution of the system. Our ordered pair is 1, 6. So we have to all we do is substitute the 1 for the x's and the 6 for the y's and see if it works in both equations. So we'll do this one first. 2 times 1 equals 4 minus 6. Alright, so that becomes 2 equals 4 minus 6 is a negative 2. So that's a big no on that one. Alright, let's try the other one. 4 times 1 equals 8 minus 2 times 6. 4 times 1 is 4. 8 minus 12 is a negative 4. 4 does not equal negative 4, so it doesn't work in either. Actually, it just has to not work in one of them, and it's not a solution to the system. If it works in one of them, it'll be a solution for that one. But no, not a solution. Okay, number 36. We've now entered the land of exponents. So I'm going to give you a brief rundown about exponents before I get started with this problem. Okay, so let's say that I have x to the 6th power. Alright? The 6, that's the exponent. The x is the base. The exponent only works on the base. So if there was for instance, there was a negative sign out there, the 6 is only telling us what to do with the x. It's not telling us what to do with the negative. Only when the whole thing is inside the parentheses. Whatever's inside the parentheses, if there's an exponent on it, the whole thing is a base. Then you do it. You do what the 6 says to the whole thing. All right. So you have to determine what the base is. And look at the base as just kind of one thing in terms of the exponent. You know. Alright, so let's say we have x to the 3rd power. Alright, well that means, what it means is it's x times x times x. That's the definition of it. It's whatever the base is times itself the number of times of the exponent. So if you have 3 to the 3rd power, for instance, it's 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27, so 3 to the 3rd power is 27. With numbers you can figure it out. If it's really a big number, it's like, say they have 3 to the 7th power and they say work it out, well then you can do it in your calculator. And in the calculator, there's a little thing called a caret. And you push the number first, then you push the caret button, and then you push the number of the exponent, and then push enter. And it will automatically do it for you. So where's my calculator? It's hiding here. So if you have 3 to the 7th power, on the calculator you put 3 and then push the caret button and then push 7, and the answer will be 2187. 2187. The answer will come right up. Okay, there's basically 3 things you really have to remember. One is, whatever you have, expand it. So in this case, we have 8n to the 6th power times the negative 7n to the 2nd power. Note that the 6 only deals with the n, not the 8. This 2 only deals with that n, not the negative 7. Okay, so what we have here, if we expanded it out, and what I mean by expanding is this, we'll take the n to the 6 and make it n to the 6. 6 n's times themselves. 1, 2, 3, 4, 5, 6. And that is times a negative 7 and n squared, or 2 n's times themselves. See, now you can just add them up. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's n to the 8th power. And then you've got your 8 times your negative 7, which is a negative 56. That's the answer. Another way to do it, after you see that, see, because this one, 8n to the 6th, well, you know there's 6 n's times themselves. And this one, negative 7n squared, you know there's 2 n's times themselves. 2 plus 6 is 8. So that's actually a better way to do it. But you need to do a bunch of problems to start remembering that that's what happens. Otherwise, you need to expand them out like I just did. Another piece of information is a number to a negative power, like negative x to the negative 1 power, equals 1 over that number to the same power, only positive. So if we have q to the negative 15 power, that is the same as 1 over q to the 15 power. On tests, you're always asked to leave the expression in a positive with positive powers, not negative powers. So you'll get points taken off if you leave it in negative powers. So you have to make these conversions. And one other thing. Okay, so basically, let's say we have one with it's a fraction. Let's say we have 6 sevenths, and that's to the negative 1 power. Well, that equals the reciprocal of that, which turns out to be 7/6 to the 1 power. If you have, let me get rid of this. Something like this, p to the 3rd power, r to the negative 2 power, over x, the 2nd power, times y to the negative 5th power. All these things are reciprocals. The negatives are reciprocals of each other, and then you can put them in positive powers. See, so that means this could go underneath, and this could go on top. And when you do that, you give them positive powers. So I would write that then as, I keep the p to the 3rd power because that's already positive. I bring up the y to the negative 5th and turn it into y to the 5th. Okay, on the bottom, I've got x to the 2nd power. My r is to the negative 2 power, so I'm going to put that on the bottom to the positive 2 power. So now I've got the same thing, except I've switched the variables with the negative powers to the other side of the fraction bar. It's as easy as that. If you can remember that. Otherwise, you could multiply it and then multiply it times the reciprocal of r, which is be 1 over r to the 2nd power, and you'll get the same thing. Remember that one, and then there's one other one that I really want you to remember. If you have a problem like this, notice the parentheses, and then we have an exponent on the outside of the parentheses. Everything inside the parentheses is the base. Everything in there is the base. So to change this you want to change this to a positive power just to start off with. Now, all you have to do is move everything on the bottom to the top and everything on the top to the bottom. Basically flip it over exactly the way it is. Now this might seem counterintuitive because I just showed you that the negatives could go on top and become positive and the positives go on the bottom. But this is a separate, you'll want to do that too, but this is a separate separate thing. So first thing we would do with this is, draw our parentheses. See if I can get it all in here. Just put this bottom part on top, and just the way it is, -2 PR, and the top part, this top part, put on the bottom, just the way it is. Q to the second power PR to the -8th. And that whole thing is now to the +3 power. Okay, so now after you've flipped it over like that and changed it to +3 power, notice everything on the top is exactly the way it is, only it's now on the bottom. I didn't change the negative signs or anything. Same with the bottom, it's on the top. Now is a good time to go and switch the negatives. So instead of leaving it the way it is, I'm going to put it over here, see if I have enough room. I'm going to put the n to the -2 on the bottom, only make it n to the second power. And then the r to the -8th power, I'm going to put that on top. So r to the -8th. Oh, it's positive now. R to the 8 now. I'm putting r to the -8 on top, becomes positive r to the 8th. The others are the same because those are still positive. Those are already positive. And then your Q2 and the P on the bottom. Okay, so you just have to make sure you've got everything where it's supposed to be. We've got the Q, the second power on the bottom where it was because it's positive. The P on the bottom, it's positive. R to the -8th, move that to the top. Got this P and R on the top because they're positive. This end to the -2, I've switched it to the bottom, made it positive. Okay, so now that's all to the third power, right? So now we can deal with the things inside. Each thing inside here is to the third power. Everything inside this parentheses, because the whole thing is the base. So r to the 8th power to the third power would be, we can make 3 of these. If we wanted to, we can make 3 of these parentheses now. If you can't do, if you don't realize that three of those r to the 8th powers is r to the 8th plus r to the 8th plus r to the 8th is r to the 24, or 3 times 8, 24. So we'll go, and then the PR, the P would be to the third, the R to the... Actually, before we even do that, we can cross-cancel a few things. We have a P on top and a P on the bottom. Let's just get rid of those right now, okay? Because they cancel each other. P into P becomes 1. Anything else the same? No, nothing else is the same. All right, so we'll rewrite these now. Got 3 of those. Hope I didn't confuse you by the little segue there. Okay, so we've got those 3 r to the 8ths. We've got 3 r's. Well, that I could have consolidated. All right, then on the bottom we've got n to the second and q to the second. We'll do that 3 times. Alright, so now we can just count them up. We've got, there's 8 and 8 and 8, that's 24, and then there's these 3, 25, 26, 27. So it's r to the 27th. I'm going to use a different color. I'll do it over here. R to the 27th. Okay, that's all there is on top. Now we'll look at the bottom. We've got n to the second, n to the second, n to the second. 2, 4, 6. 6 of them. N to the 6th. Q's. Q to the 6th also. So there's our answer. R to the 27th, n to the 6th, Q to the 6th. Okay, obviously you've got to do a few of these to keep this straight. But those are the 3 things you need to keep track of. Okay, for clarity's sake, we'll just do this rather complicated problem over again. Okay, so starting off with this, having this negative exponent, let's flip the whole thing over exactly the way it is. So I'm going to put n to the negative 2 PR on top, q to the second PR negative 8 on the bottom. Okay, now that's to the positive 3. Now let's look in there, see if there's anything we can cancel out. Well, we can cancel out these p's. Alright, now let's send our negatives to the opposite side of the fraction bar. Let's do that next. Okay, so we've got this n minus 2. We'll put that at the bottom, but it's going to be positive now. Okay, we've got this r to the negative 8. That's not n minus 2, it's n to the negative 2. Okay, we have r to the negative 8th power. Let's put that on the top, but with a positive power. Okay, now let's just keep everything else that's up there already. There's an r up there, and then we've got this q to the second power, and the p is gone. Okay, so we're done with that so far, and then we still have that positive 3 exponent. Since I've run out of room, I'll recopy down here. And I'm going to simplify the top. See, we have r times r to the 8th. So r to the 8th means r times r times r times r 8 times, right? So we've got 8 of them. Well, if we add the other r, that makes r to the 9th. So let's just change that. R to the 9th. This is not exactly the same way I did it last time, but you'll see we're going to get the same answer. And I would recommend that you try to do it different ways also. And I don't mean make up some new way to do it. I mean, you know, take a different approach. Instead, equalize the stuff or simplify the stuff inside the parentheses first, and then deal with the negative exponent on the outside. You know, try a few different ways and see that you get the same answer, and figure out what way works best for you. Alright, so let's finish this up. We have r to the 9th, so there's 3 of those. 3r to the 9th times r to the 9th times r to the 9th, and that would be 27 of them, right? So we have r to the 27th. Okay, then we have 3 of these n to the seconds. N to the second times n to the second times n to the second. That's n to the 6th. And 3 of those q to the seconds, which will be q to the 6th. And there's our answer. R to the 27th over n to the 6th, q to the 6th. Okay, so much for part 3. Move on to part 4.